Good afternoon, everyone, and thank you for joining Hosokawa's webinar on agrochemical process equipment and considerations. My name is Greg Boyer, and I'm the Marketing Manager for Hosokawa Micron Powder Systems. If you have any questions during the presentation, please use the Q&A panel on the right side of your screen to submit your question. We will answer as many as possible at the conclusion of the webinar. Hosokawa Micron Corporation is a global leader in powder processing equipment with headquarters in Osaka, Japan. We employ over 1,500 employees worldwide, have production facilities in 5 countries, and 12 technical centers and research facilities. We design, manufacture, and assemble equipment for size reduction, classification, mixing, containment, isolation, compaction, and laboratory analysis. Our equipment is designed for the chemical, food, pharmaceutical, and mineral industries. At this time, I'd like to introduce our presenter, Chris Paulsworth, our in-house expert on mixing and drying technologies.
Thanks for the kind introduction, Greg, and welcome everyone to today's webinar. Today we'll be discussing the typical agrochemical manufacturing systems, the normal production stages of mixing, drying, milling, agglomeration, and containment, and also special considerations for processing crop agents. Throughout the length of the discussion, we'll be discussing protecting operators and controlling hazardous materials. So what are the typical steps for agrochemical processing and manufacturing? Well, it normally begins with a synthesis step, which is normally aqueous or involves some sort of liquid-based chemistry. After that, there's nominally drying, mixing, in which you'll take the dried material and add additives, size reduction, which you'll take all those manufactured chemicals and make them into the same size, post-blending, and then agglomeration to produce your final product. We offer solutions for drying, mixing, size reduction, post-blending, and agglomeration. So these will be most of the steps that we'll be discussing today. So let's start by giving an example of a formulation process. In this process, we start with a feed product up here that's been dried. We would feed it into mixers that would homogenize the product, and then you can add additives into that mix to form further homogeneous product. From there, you can mill that and collect the milled product in mixers, further adding any final additives before packaging. So what are we going to consider as we go on today? We'll consider explosivity. A lot of these ingredients and additives are explosive. So we'll talk about how you can deal with that and which processes explosivity needs to be considered for. We'll talk about particle size distribution, how the equipment affects it, and which equipment will provide which particle size distribution. Temperature sensitivity, which will be more about which processes generate heat and then how much that you can expect that to affect your product. Abrasion, which is common in almost all processing equipment and can be compensated for. And toxicity, which for active ingredients should be considered. So the first step is drying. For drying, you can select your dryer nominally based on 2 ways, the product or the process. If you're basing your selection on the product, what you consider is the form and feed of your product, the liquid and solid properties that you're feeding into the unit, the initial and final moisture content, and the toxicity and other safety hazards. If you're selecting the dryer based on the process, you can consider whether you're looking for a continuous or batch process, whether you have a low throughput or a high throughput that you need, whether your product changes during drying, if you have a low or high evaporative load, and if you have any upstream or downstream process fluctuations. So the first type of technology that we'll be considering for drying is the vacuum dryer. The way the vacuum dryer worked is product is added into the vessel. Inside the vessel, you pull vacuum and you add heat into the system through the wall. The heat interacts with the product and evaporates the liquid off through The liquid comes out through the vacuum filter onto the primary condenser. Beyond the condenser is a vacuum pump and a secondary condenser. You also have condensate receptacles and a heating and cooling skid. We offer different models of vacuum dryers, and these models can do different things based on the configuration of the auger. So for the upper versions of the auger, you have a helical type and a paddle type. These types of augers have more motion within the batch, which is going to give you a faster drying rate because they're going to be refreshing the product near the wall. Other than that, you have an auger type, which is going to be a slower drying rate. However, these upper types will not be able to handle as wide of a variety of products as the Nauta type. So what are the considerations? For explosivity, vacuum drying is less of an issue because you have vacuum, no oxygen. Also, you have so slow speed, so you're not going to be generating sparks inside the batch. You're using vacuum to dry your product, so it's also good for temperature-sensitive products. And because it's a gentle process, you're going to get minimal size reduction. You're also going to get low abrasion because you have a slower process. As a side note, because it's a slower process, it's going to take longer to dry your product. Moving on, we have our DryMeister DMR flash dryer. Now this is a continuous process and can give you a final moisture of about 5 to 10 weight%. The way it works is the product gets dropped into a hopper and fed into the dryer. Once inside the dryer, it falls onto this spinning rotor at the bottom, which is going to disperse the product in air. Once the product is dispersed in air, hot air is going to come in through the bottom, up around that dispersed product, and dry it out. The dried product is then carried by the air up to an air classifier. What the air classifier will do is that product that's fine enough will go through the air classifier, and product that is still too coarse will get rejected and sent back down for more drying. The way the systems look is that the product gets dried in the DMR, conveyed up to a bag house, and then the entire system is on suction via a blower. Now this is a closed loop system, so it would be ideal for a product that has to be dried in an inert atmosphere. The temperature is added, or the heat is added into the system by the burner on the front end here. So what are the considerations for this type of dryer? Obviously, explosivity needs to be considered because this can generate an explosive dust inside the dryer. You're using heat to dry, so temperature sensitivity also needs to be considered. And this type of system is less applicable for a temperature-sensitive product. You have the dispersion disk rotating in the bottom, so you can cause some degradation, shifting your particle size finer, and abrasion, obviously, for this type of system. On the other note is that this system can handle variable types of feeds, including pastes, slurries, and filter cakes, and you can vary the moisture content within that feed or amongst different feeds, so it's very flexible. Moving on from drying, we have mixing. Mixing is similar to drying. You can select the mixer based on the product or the process. For the product, what you could consider is if you have a cohesive or a free-flowing powder. The quality of the mix required, that tends to be based on the sample size and how big of a product your end customer is going to be using. The fragility of the product, some mixers that mix more rapidly can be more intense and can break up a fragile product. And again, toxicological data and safety hazards, which should always be considered. You can then move on and select based on the process. You can consider if you're looking for a continuous or a batch operation, the throughput and production capacity is required, and upstream and downstream processes and fluctuations. The first type of mixer we'll be discussing is going to be the Vrico Nauta conical screw mixer. Now this is a low shear mixer. The way that it works is you have an auger within the mixer. The auger pulls the material up from the bottom of the mixer and deposits it at different locations throughout the batch and is rotated around the batch by an orbital arm at the top. What are the considerations for this type of mixer? Explosivity is less of a concern here because you have a very slow and gentle mixer. And because of that also, you're not going to be generating much heat and you're not going to be shifting your particle size. Also, you're going to get minor abrasion, although we can do wear protection on the auger to prevent abrasion in that portion. As the other notes, this is a large, gentle, and slow process. For low to mid-shear mixers, we have the central paddle mixer. The way that this mixer works is that you have paddles around the outside of the vessel. The paddles rotate, lifting material up to the top of the batch, and then it falls back down through the middle. So what are the considerations for this type of mixer? This type of mixer is going to be a more rapid mixer than the low shear mixer. So you can have enough speed where you can actually fluidize the batch inside, causing a situation where you can have an explosive dust cloud. You're still going to see minimal temp increase, but it may be higher than you would see on the Nauta. For particle size distribution, you're going to see minimal change in the particle size, but it is possible to see abrasion because there are higher speeds in this type of mixer than in the other. And one final note is that this type of mixer requires a free-flowing powder, similar to the more complex auger types that we were discussing for the vacuum dryers. The final type of mixer that we'll be discussing is the Cyclomix high shear blender. This type of blender is the most intense mixer that we make. And what it does is it has paddles going around the outside, but those paddles are actually in opposite directions based on alternating in opposite directions, excuse me. What that does is as they rotate, it creates currents inside the mixture that add shear, and that shear can cause changes in your product, such as rounding or bonding particles to each other or coating larger particles in smaller particles. You can also see that this vessel has a jacket. That's because this type of mixer is going to generate a significant amount of heat. So obviously, because you have a more intensive mixer, you're going to have to worry about explosivity. You can make these in pressure shock resistance or inerted construction. And as mentioned last time, temperature sensitivity needs to be compensated for with the jacket. You will see some shift in the particle size if you have a fragile product, and we do consider abrasion for this type of mixer. As a side note, though, this mixer is good for coating and rounding particles. Moving on, we have size reduction, also called micronization. For this, again, you can select based on the product or the process. For selecting based on the product, you select based on the abrasivity of the product, the hardness, and the particle size distribution of your end goal that you're looking for. If you're selecting based on the process, you can select based on the feed size, which is just that some milling processes need a pre-milled feed, so they would be less flexible. Before we get into the details of all the different milling technology, we'll discuss the toxicity. For milling, you have to consider toxicity for every type of mill. If you have a highly toxic product, what you can do is take the mill and put it into an isolator or a containment system. What this will do is contain the system and provide your operators with the highest amount of safety. All these systems are custom designed and are available in a wide variety of sizes and configurations. For explosivity, this also needs to be considered for every type of mill. To compensate for explosive products, we tend to go about it in 4 ways. You can inert the system, you can create the system with such strength that it can withstand an explosion, you can suppress an explosion, or you can take the explosion and vent it to a safe area. So moving on, we'll go on to the specific types of equipment that we use for size reduction of agrochemicals. To start, we'll discuss the micropulverizer, hammer, and screen mill. The way it works is you have 2 sections, grinding and screening. For the grinding sections, what happens is the hammer impacts the particle and breaks it up. The pieces are pushed outward towards the liner. The liner takes these pieces and directs them back into the path of the hammer, allowing for multiple impacts. As you move around, you get multiple impacts down to the bottom of the mill where you have a screen. The particles are moving tangentially to the screen, and so you have a much smaller hole, and they will either slide through that small hole or bounce off it and get milled further. These systems tend to come in two configurations: bunker style, in which the mill sits directly on top of a hopper, or air conveyed style, in which the product coming out of the mill is conveyed to a cyclone or a baghouse and then possibly screened to give you your final end product. The cyclone is interesting in this type of system because what it does is it allows you to run multiple different products and not have to do as much cleaning. So if you wanted to mill multiple products, you could clean only up to the cyclone and not the dust collector between each batch, allowing you to have a quicker turnover time and do more different types of products. So what are the considerations? Obviously, explosivity needs to be protected. This type of mill is going to give you a medium to high temperature increase. You're probably talking 20, 30, maybe even 40 degrees. For the particle size distribution, it's going to be controlled by a screen, but the screen is a pretty good but not great control mechanism, so you're going to get a medium to wide particle size distribution. And abrasion, for these mills, we can compensate with wear protected parts, but there's a lot of parts inside. So if you have a very abrasive product, we would say you might want to consider a different type of mill. Moving on, we have pin mills. For pin mills, the way that it works is the product gets fed into the middle, and you have a stationary disc on one side and a rotating disc on the other side. The product gets impacted off the pins and bounces between the pins, between the rotating and the stationary pins, and works its way out. Once it gets out to the outside, it falls around to the bottom where it can be discharged via gravity or air convey. There's two ways that we configure these systems similar to a hammer mill. Bunker style, in which the mill sits directly on top of a hopper, or air conveyed style, in which the product gets conveyed out of the bottom of the mill into a dust collector. So what are the considerations for this type of mill? Obviously, it needs protection to deal with an explosive product. The temperature gain on this type of system is going to be less than compared to a hammer mill. So you're going to get less heat, making it more suitable for a temperature-sensitive product. It's going to give you a wide particle size distribution, but it's going to give you a finer end product than you would see for a hammer mill. For abrasion, these systems have a lot of small parts, so they can be hard to wear protect, making them very difficult for abrasive products. We can make the pins out of hardened metal, however. Moving on, we have the air classification mill. For an air classification mill, the way it works is that the feed comes into the side of the mill, into this zone here where you have the hammers rotating on a disc at the bottom. The feed gets impacted by the hammers and gets carried up by air that's pulled in through the bottom of the system and around the disc. The product that's milled gets carried up to the classifier. The classifier is going to accept fine particles through and reject coarse particles back down to the milling zone. The fine particles get carried out with the air to the dust collection. These systems look similar to the air conveyed systems for the other types of mill, in which you have the mill and then the product is conveyed out via air to a dust collector. So what are the considerations? You're going to get a medium amount of heat generation. Compared to the other types of mills, the entire flow of air that's conveying the product is going to be going through the mill. And that's going to give you less heat generation for this type of mill than you would see for a hammer mill or a pin mill. Because you have a classifier inside, it's going to give you a narrow particle size distribution. And if you have an abrasive product, we would wear protect the hammers and the classifier. Moving on, for a very fine product, we have what we call the AS spiral jet mill. For the spiral jet mill, the way it works is the product gets dropped in through the top and fed in using compressed air into this opening right here. The products spin around inside the chamber, bouncing off other products or other particles of the product and the wall, causing size reduction. The products, as they get finer, move into the center and discharge out the center and the back. So what are the considerations? For this type of mill, the entire air, all the air in the system is going through the mill, again, causing low heat generation. For the particle size distribution, you're going to see a medium to wide particle size distribution. You're going to get a much finer product with this type of mill, but it will still be a wide particle size distribution because there is no classifier or no real size control inside the mill. For abrasion, you're going to see a medium amount of abrasion. The product size reduction is caused by impact on other products and on the wall, so that needs to be compensated for. And if you look at this mill up here, what you can see is actually a ceramic body, so we can make these mill interiors out of ceramics, helping to negate the abrasion. One thing to note is that there is limitations on the feed size for this type of mill, so you may need to pre-mill your product before feeding it in. Moving on, we have fine grinding using the AFG fluidized bed jet mill. For this type of mill, what happens is the product gets dropped in through the top and falls into the bottom of the chamber. In the bottom of the chamber, there are air nozzles. Product falls into the air and pushed into the center of the chamber where it impacts other particles of the product. The impact causes the size reduction, and once the product is fine enough, it gets carried up to the top of the chamber. When it's at the top of the chamber, the coarse products get rejected and sent back down to the bottom, and fine products go through. This is a normal configuration of a fluidized bed jet mill. The feed comes in through the side, milling chamber in here. The product gets carried out to the cyclone and then onto a dust collector. This is the finest of all types of milling systems that we offer. It can give you a D99 down to even 7 microns for some products. These mills are good for temperature-sensitive products because they have low heat generation. They also give you a narrow particle size distribution. For abrasive products, they work relatively well. You're not using any mechanical items inside the mill to do particle size reduction, so there's less cause for abrasion, but we do wear protect the classifier. Moving on to post-blending. For post-blending, this is going to be similar equipment to the primary blending step. However, you're going to have a smaller particle in this step of the process, so it's nominally going to be more cohesive. So you may need to select a different type of mixer for this type of process. The next step we're going to be discussing is agglomeration. For agglomeration, we use what we call the Flexomix. The Flexomix is specifically applicable to agrochemicals because we use it to create what we call a water dispersible granule. The way that the system works is that dry feed is fed into a chute on the side and falls into a mixing chamber, which is this red section here. Liquids are sprayed in through the top through these nozzles, which are pointed directly down into the mixing chamber. As the product falls in, it gets dispersed by the rotor and mixed thoroughly with the liquid that's sprayed in. What it gives you is a cluster of agglomerates where you have powders that are encapsulated in liquid and stuck together. The way that these systems work is that coming out of the Flexomix, you often fall into a fluidized bed dryer, and the fluidized bed dryer will evaporate off the liquid. Following the fluidized bed dryer, you go to a screener which can take out any large agglomerates, and then you can collect the product. So what are the considerations? For explosivity, this can be an inerted system, so you can run it with nitrogen to help control an explosive environment. It's going to require heat to dry the product, so this heat can be bad if you have a temperature-sensitive product. You're going to get a medium to wide particle size distribution, so we recommend screening for an oversized product. There's going to be low abrasion in this type of system if you have an abrasive product, so that shouldn't be of any, we don't need to make extra considerations for it. And another note is that if you want to generate a low pressure extrudate, these systems are common generating feed for that type of system. What you would do is go directly from the Flexomix into the low pressure extruder. You're going to get a good pre-mix before your extrusion step, and you can also often benefits the operation of the extruder. So moving on, we have powder densification. For this, we use what's called the micron dense pack. The way that this works is product gets fed in through the top into a rotary valve with a screen in the inside. The screen removes the air in between the products, densifying it as it goes through. Once it gets to the bottom, a pulse of compressed air is going to push the agglomerates out the bottom. These products can increase the bulk density from 30% to up over 100%. One final piece of equipment we'll be discussing is going to be downflow booths. The way the downflow booth works is that you have downdrafted air, which is going to take any particles that may be entrained in the booth and push it down to a filtration system, which removes it from the air. These systems tend to come with three types of filters: primary, secondary, and HEPA filters, and a fan that's going to recirculate the air. We use these systems for two main reasons for agrochemicals. We use them for sampling booths, in which you would take multiple different products, put them in the booth, and remove samples. This allows you to remove multiple samples in a safe environment and not have your operators interacting with high amounts of entrained particles during the day. The other way that we use them is for filling systems. If you wanted to fill bulk containers such as drums or totes, we can put the filling mechanism through the top of the booth, allowing safe operation for your operators. So to conclude the presentation, when selecting equipment for processing agrochemicals, there are many things to consider. We make equipment that takes these considerations into mind. Thank you for your time.
Thank you, Chris. We're now going to start the Q&A session. As mentioned earlier today, we will try to accommodate as many questions as possible. If we're unable to answer your question live during the presentation, Chris or someone else from Hosokawa will get back to you shortly. Okay, Chris. All right, first question. Which vacuum dryer works best for slurries?
We have a couple different models of vacuum dryers as discussed previously. Let's go back. So if you wanted to select based on what is your product consistency for a slurry, you could probably go with the Nauta type. You may be able to go with the paddle type. One thing to consider when selecting your type of auger is it doesn't always depend on the product consistency. Often the consistency within the mixer or the dryer can change based on the moisture content at that stage in drying. So you may feed in a slurry or a paste, but it may turn into like a thick mud during drying. So if you go through one of these difficult to process intermediate stages, you may need to select your auger based on that difficult stage rather than based on the product that you're feeding into it or the product that's coming out of it.
Okay, thank you. Next question. How do your mixers fare against other mixing technologies such as ribbon blenders or V mixers?
For ribbon blenders and V mixers, our mixers they're really just a different type of mixing technology. Those mixers can work very well. A V mixer is very good for a free-flowing powder. It's a diffusive mixer, so most of our mixers are convective mixers. What we do is we generate a convective current within the mixer, taking product from the bottom and moving it up to the top. A V mixer, what it will do is it'll rotate and the product will diffuse down the batch. the V mixer is a gentler mixer, but it can have some difficulty if you have a difficult to mix product. For a ribbon mixer, they're a convective mixer as well. The advantages of ours over theirs is that you're going to get a full discharge out of our batch. The advantages of their mixer is that you're going to have a little bit of a quicker mixing time because you have more motion within the batch.
Okay.
We've got a question here. If we have material buildup using a pancake air jet mill, what strategies can we use to minimize buildup? So to minimize buildup, you may be able to use a higher airflow, although that's going to affect your particle size. It could be related to moisture in the product, so you could try drying the product in advance. I mean, it can be a difficult one. I would guess that it's moisture related. There's very little reason for material to hang up, so that would be my guess.
The same customer asked a second question. Also, with an AFG fluidized bed jet mill, is the material buildup a concern or a problem for lower melting materials?
Normally, no. You have a very high flow of air through these types of mills, through both the pancake and the fluidized bed jet mill. So normally, they're going to maintain a relatively low temperature. You can see product buildup. Like if you overfeed the mill, what you can do in a fluidized bed jet mill is put too much material into the bed, and it can be too dense. So what you need when you're looking at this type of mill is you need the particles to be able to be carried by the airflow into the center and impact the other particles at a high speed to get the size reduction. If you have too many particles in the bottom of the mill, what they can do is, on their way into the center, is they can start hitting other particles, and that can cause less size reduction than you would hope for.
Next question. Do you recommend a filter press or centrifuge for drying product?
We do. I kind of jumped through some of the early steps here. If we go back to the typical agrochemical process steps, you start with synthesis and you go to drying. And I talked right away about flash drying and vacuum drying. These are both thermal drying steps. So what you're doing is you're using energy, either energy, flash drying, you have the hot air going right up around the product and drying it, or vacuum, where you reduce the temperature or you reduce the pressure within the batch and then use energy under vacuum to evaporate the product. It's always going to be more energy efficient to use mechanical drying first. So we would always recommend that you use a centrifuge or a filter press to get a suitable feed for these types of dryers.
Okay. Next question. How do you mill ingredients that soften at low temperatures?
We kind of hit on this earlier, but for low temperatures, the trick is going to be to use a mill that has most of the air going through the mill. So for instance, if you look at, let's go back. Oh, sorry. Let's go back to this type of mill. If you look at the hammer mill, for this type of mill, the feed goes through the mill, but there's no air going through the milling section. It's really just product going through the milling section, allowing heat to be generated during the process. If you go on to an air-conveyed milling style, the entire amount of air is going to be going through the mill, and this is going to be keeping it cooler. So if you have something that's very temperature sensitive, we'd recommend going for an air-cooled mill. Also, as a side note, you can use probably a hammer mill or a pin mill with some sort of cooled configuration, so you can cryogenically mill the material. And even more complicated, I guess, for the ACM, you can pre-cool the air going through just by putting an air-to-air heat exchanger or a air-cooled heat exchanger there to help control the temperature of the inlet, therefore reducing the temperature on your outlet.
Okay. Next question. What's the production rate of an air classifying mill?
You can get a pretty wide range of production rates for all of this equipment. It can vary between, I don't know, 40 kilograms an hour up to tons and tons per hour. Really, all of this equipment and most types of equipment is going to be available in a variety of sizes. One thing that you have to consider when you're looking at sizes is a continuous process is always going to be smaller than a batch, in general, is going to be smaller than a batch process. So that can be something where you have to consider your throughput rate.
We've seen a few customers here also ask if the slides will be available after the presentation. The answer is yes. We'd be happy to share the presentation with anyone who would like a copy of it. If there aren't any other questions, what we'd like to do is conclude the presentation here on the slide with Chris's contact information. So that way, if anyone has any additional questions, you can reach out to him.
And we have test centers for most of this equipment in New Jersey, in the USA, of course, in Japan, the Netherlands, Germany, and Brazil.
Okay. Oh, we have one more last question that just came. Is it preferable to have a medium-sized reduction mill before an air jet mill?
That is going to depend, really. If you have a spiral jet mill, I would say yes. If you have a fluidized bed jet mill, I would say it depends. In terms of energy usage, the finer that you're grinding, the more energy you're going to use. So a fluidized bed jet mill is going to use a lot more energy than, say, a hammer mill. So you may be able to save some energy by pre-milling your material in a hammer mill before feeding it into both types of mills. But then again, you do have more equipment in your facility. So it can be a trade-off.
Well, thank you so much, Chris, and thank you everyone for joining us today. This webinar has been recorded, and we will be posting it to our website in the next 24 hours. If you've registered for this webinar, you will automatically receive a link to the video once it's completed. If you have any additional questions, please feel free to reach out to Chris with his information above. We thank you for joining us today.